Okay, on number 7, we're going to take a look at another instance where it's not differentiable, where we have a continuous function that's not differentiable. So we're looking at the function f of x equals x to the 1/3 power. So just to give you an idea of what this looks like, you'll notice this is of course the cube root of x. That's the same thing, x to the 1/3 and the cube root. That's the inverse of our function x cubed. So you should all know what x cubed looks like. Now think about reflecting that across the line y equals x, and you'll have a good idea of what this graph is. If you don't have a good idea, you can just plot some points. 0, 0, 1, 1. Then the next thing that you can take the cube root of is 8. So the cube root of 8 is 2. And it's going to look the same way in the other direction. So looks like this. I may not have gotten that steep enough right there. It's a little steeper. Yeah, now it's a big mess. You get the idea. Okay, so is f of x continuous at 0? Well, yeah, of course it is. Okay, so now what we're going to do is we're going to look at the slope, the derivative, as we approach 0. Okay, so we're looking at the limit as x approaches 0 of f of x. F of x is just our function, minus f of 0. You plug in 0, you just get 0, or x minus 0. Oh dear, I forgot the limit. We can squeeze that in there. The limit as x approaches 0. Okay, so this is the limit as x approaches 0. Now, obviously, the zeros don't matter here, so we have x to the 1/3 over x. If you subtract your exponents, that's x to the negative 2/3. So 1 over x to the 2/3. All right, now if we plug in 0, well, you can look and see that's an asymptote here. Okay, this function would be a vertical asymptote there. Or what you can do is you can think about plugging in something really, really close to 0. So if you plug in a teeny tiny number, like 0.00001, take it to the 2/3 power, it's still a teeny, teeny, tiny number. And then 1 divided by this teeny, tiny number is going to be infinity, okay, a very large number. Okay, so what this means is the tangent at x equals 0 is vertical. Okay, so the slope right at this point is actually a vertical tangent. So we can't differentiate vertical tangents, so this is not differentiable. Okay, so those are a couple examples of cases that you would have a continuous function that's not differentiable. If it has a sharp turn or if it has a vertical tangent somewhere. So just kind of the last couple ideas in summary of what this lesson's about. If you have something that's differentiable, then it's continuous. But being continuous does not mean it's differentiable. And the two that we looked at were those sharp turns and vertical tangents.